Hi, Year 3, Mr. Jones here again on the 13th of January 2021. I'm just going to underline my dates using a ruler. Can't see that, I'm doing that anyway. Okay, so what we're going to be doing today, we're going to be looking at problem solving, but just want to go over. I've noticed that we are getting better at our 8 times table. Keep learning them, just keep working on them every day of the week, 5 or 10 minutes here or there. Just work at 1 times 8 is 8, 2 times 8 is 6, and also the division facts, the related division facts, and you'll soon get them. Worth really putting a bit of effort in, and then you'll never forget them. They'll be with you forever. They'll be stuck in your brain forever. Okay. Yesterday we looked at the trick of doubling, doubling, and doubling again. So if we know the 2 times table, we can know the 8 times table in effect. We looked at that yesterday as well. Okay, just a quick reminder, fluency first. What I'd like to just do is just to think about, remember, multiplication. What is it? I'm just thinking about these problems. Number of, what do we call it? Number of groups times the number in each group. So here we've got a representation of a number sentence, and that representation would be how many groups. We've got 3 groups of how many objects in each group. 3 groups of 8 would be 3 times 8, giving me 24. Okay, so how many groups, how many in the group. Okay, quickly count up in 2s. 2, 4, 6, 8, 10. Count up in 4s. 4, 8, 12, 16, 20. Counting up in 8s. 0, 8, 16, 24, 32, 40. We'll notice here, again, like we said, times in by 2, doubling, and doubling. The relationship between the 2, the 4, and the 8 times table. Okay. Any number in the 8 times table will be in the 2 times table. Any number in the 8 times table, any number in the 8 times table will be in the 4 times table as well. Okay. So any number that's in the 2 times table won't necessarily be in the 8 times table, because we've got 2, 4, 6, 10. But any number that's in the 8 times table will be in the 2 times table. Okay. Write them down and have a compare of the 2, the 4, and the 8. And you can see the relationship between the 3 different multiplication tables. Okay, fluency first. What I'm going to do, you can copy the link. Our old favourite. Look this one.
Monster Math Prisons.
Just a bit of reggae. So you know that one. So enjoy that 8 times table. That song, sing along with it. Always good practicing that 8 times table. Okay. Then again, keep writing out your 8 times table at every opportunity. 0 times 8 is 0. 1 times 8 is 8. 2 times 8 is 16. 3 times 8 is 24. So forth and so on. Okay. So that's our fluency first, to keep on keeping on with our 8 times table. Okay, let's see what new learning we're doing today. Okay, so what we're using today is the bar model to solve multiplication and division word problems. Keep on thinking about problem solving so that we can work out how many flowers Amal has. Okay, when we learn our times tables, we can learn times tables, but it's often applying our mathematical knowledge, that's the difficult thing, into real life situations. But that's really what we need maths for. We need maths to solve problems. We might come across a carpenter as a carpet layer, accountant, any of these trades will use maths. You know, and if you go down to the chip shop, you perhaps need to work out how much do 4 packs of chips cost. So it's really important that we use our mental maths skills, our timetable skills, to solve real life problems. And that's what we're going to look at today, particularly with the use of the bar model. And all the bar model is a little sketch, a diagram, a representation of a mathematical problem. Okay, so we'll be looking at that in more detail today. Okay, so there's our blog. Use the bar model to solve multiplication and division word problems. How? Deep thinking by problem solving, so we can work out how many flowers Amal has. Okay, so we're going to go into the book. Let's have a look. Okay, so here we go. We've got somebody in a polytunnel holding bunches of flowers. Let's have a look at question 1A. Okay. Question 1A. The plants are planted in rows of 4. I think it's talking about these. There are 24 to plant. How many rows of plants will there be? Okay, so what's the key numbers here? 4 and 24. They're the key numbers. Okay, so if I want to represent that, so we've got rows of 4, and we've got 24 plants. Number of rows. Okay, so let's have a look at it. 1 second. I'll just change the screen. Okay, so we've got rows of 4 plants. My total number of plants is 24. My total number of plants. 24 is the total. I could put 24 in here. This is what we talk about bar model. Okay, now we're going to split those into 4s. So if we go 4, 8, 12, 16, 20, 24. Okay, so 1 4 is 4, 2 4s are 8, 3 4s are 12, 4 4s are 16, 5 4s are 20, 6 4s are 24. Okay, so we could do an array. So we've got 4 in a row. This with dots. So 4, 8, 12, 6, 4, 8, 12, 16, 20, 24. Okay, so we've got 1 row, 2 rows, 3 rows, 4 rows, 5 rows, 6 rows. Okay. Or we can do the bar representation. The whole thing is going to be 24 plants. And we've got how many groups, how many rows? 1, 2, 3, 4, 5, 6 rows of 4. Okay. So that's called an array, which you often see with the red counters or yellow counters. The mathematical term we used in an array. And this is a bar model. It's just a quick sketch that helps us solve mathematical problems. Okay? This is only a one-stage maths problem, so it's quite straightforward. But it's very useful sometimes, particularly when we go into fractions or comparing fractions or percentage problems, for the children to get used to bar models. Okay? It's a really good way for children to visualise questions and problems. Okay, let's go back on the screen. Okay, so how many rows of plants will there be? There'll be 6 rows of 4. Okay, let's have a look at the second question. My pointer. So Amal has some bunches of flowers. There are 10 flowers in each bunch. We've got 10 flowers in each bunch. How many flowers does he have in total? Okay, so again, let's have a think. He's got bunches of flowers. How many bunches is he holding? He's holding 3 bunches of flowers, each with 10 flowers. Amal has some bunches of flowers. There are 10 flowers in each bunch. How many flowers does he have in total? Again, you can just draw quickly a little bar diagram for that. Basically, it is as simple as that. He's got 3 bunches or 3 groups of 10. So I can go over this. That 3 groups of 10, I can either write it like this as 30 or 30. It's a representation of what the question is asking. 3 bunches or 3 groups of 10 flowers. The whole thing, how many flowers in total or in totality, is 30. Straightforward. Okay, so let's have a look. Let's have a look at the representations that they've used in the book. So, like an array here, simple array, use a number line, 1 row, 4, 8, 12, 16, 20, 24. Or we can do the bar model, the number sentences underneath, 6 rows of 4 plants. So this is the girls saying, I put them into groups of 4 using a bar model. I added bars until I got to 24. Question B, 10 flowers in each bunch, 3 bunches. So we do the 3 times 10 first, and we end up with 30. So a bar model can be used in divide or multiplication questions. Really useful. May not be for these simpler problems, but certainly as we move up the school and move into year 7, 8, 9, 10, bar models are really quite sophisticated. They can be really sophisticated. Serious mathematicians use bar models to help them visualize problems. Okay, let's go on to our next think together. Okay, how many plants are there in total? Okay, first of all, what are you going to count? Columns or rows? What do you think? Okay, so I'm just going to go, I'm going to count 1, 2, 3. These are my columns, these are my rows. I'm going to count here 1, 2, 3, 4, 5, 6, 7, 8. Okay, I know there's a row of 8. So 8 here. It'd be quite good when we do area. If you think of arrays like this. Okay, so how many lots of 8 have we got? 3 times 8. Okay, if we know our 8 times table, it would be 4. Now, what about this? How many lots of 4 would it be? If I do this, I would get 1 lot of 4, 2 lots of 4, 3 lots of 4, 4 lots of 4, 5 lots of 4, 6 lots of 4. I know I've still got the same amount of plants. Okay, just the same answer. Okay, so what I've done here, I've doubled the 3 to become 6, and I've halved the 8 to become 4. That's the same answer. Can we take that one level further? What if we group it into twos? How many groups of 2 have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we've got 12 lots of 2. So what have I done? I've doubled the 6 to get 12, and I've halved the 4 to get 2. Guess what? I've got the same amount of plants. Halving, halving again. So the total number of plants is 24 plants. Okay, second part. 30 flowers are shared equally between 5 vases. This is a sharing question. I've got the 30 flowers, so you can imagine the 30 flowers in 5 vases. I could share them out. I could go 1 for you vase, 1 for the second vase, 1 for the third vase, 1 for the fourth vase, 1 for the fifth vase. Okay. Or I can think of it, what is 30 divided by 5? Okay, I know Winfield was doing this. 30 divided by 5 equals this number. Now, I can use my knowledge of the times tables to go missing number times by 5 equals 30. What number times by 5 equals 30? What number times by 5 equals 30? 5, 10, 15, 20, 20, 30 is 6. So again, I'm using my multiplication knowledge that 6 times 5 equals 30 to solve a division problem. So therefore, when I do my bar diagram, I could share them out between the 5 vases, but I'm using my mathematical knowledge to solve the problem for me. Then I need to write it up as a number sentence. My answer is here, my 30. Okay, there are five vases with 6 flowers in each. Be 30. And for completeness, I like a number sentence, a written sentence to represent that. There are 30 flowers in each vase. Okay? So I'd be very pleased with that. I think I've got them right. I know my times tables. Okay, let's go on to our challenge. Claire buys 8 small plant pots and 4 large plant pots. The 4 large plant pots cost the same as 8 small ones. So 8 small. How much? What don't we know here? We don't know how much the large plant pot cost. Let's work out the total of the small plant pots. How many small plant pots are there? 8. How much does each one cost? 3. What's 8 times 3? 8 times 3. Ooh, look at this. The 4 big ones cost the same. So remember in earlier questions, I'm just going to leave this. What have we done here? We've halved this. What do you think we have to do with the other number? I think I'm going to leave you to that to solve that question. That's a nice one. We'll perhaps go over it tomorrow. If you think about, remember we were doubling and halving the same results at the start. Have a think about that. Okay, what we're going to do next is we're going to go on to our problems that we're going to solve ourselves. And that's your turn to get stuck into questions. And the questions today we will find on page 133. Problem solving multiplication and divisions using bar models and representations, and then having to go at 134, 135. Okay, so just leave those if anyone's having trouble getting on online. I'll just leave in freeze frame there. Okay. Okay, hopefully that's the lesson finished. I'll see you all tomorrow and keep well. I'm looking forward to seeing your work.